Hi, I'm Chaitan, and welcome to Recitation 0J Dataloaders. So the purpose of this notebook is to understand the main concepts behind the PyTorch dataloader, and we'll also walk through a pedagogical example of how to use the dataloader itself. Specifically, this notebook will cover what is the PyTorch dataloader, how to initialize it, on-the-fly data loading, different batching strategies and some customizations, how to use the collate function, and lastly, some GPU and memory efficiencies. So where does the data loader come into play with respect to the model training workflow? So once we have data, and as you guys will learn in lecture, you want to batch the data for more efficient memory usage as well as training runtime. And to do that, we can, one, just loop through the data itself and iteratively slice the data into mini batches. And what PyTorch does under the hood is essentially this using the data loader object. Now we can see where the data loader will come into play. Here is an example of a dataset class that has two lists, input and target. And inside this class, you can get the length of the input, which is corresponding to the length of the output. And you can index the lists themselves. That's all this class does. Now let's see how we can use this class to create a data loader object. Here we can define our input as numbers ranging from 0 through 9 and our output as ranging from 0 to 20 by multiples of 2. Using that, we can either index the data set itself or use the get item function as shown here. What's important is the data loader object will just use the get item function. Now, if we actually wrap the data set in the data loader object, we see it prints out tuples corresponding to the XY pairs outputted from the get item function. And as you can see, every input maps directly to 2 times itself as the output. A quick segue is on-the-fly data loading, which allows us to save some GPU memory by loading the data itself, not in the init function where you would normally load all the data, but rather in the get item function. As in, you only load the data and take up that memory space when you're actually using that data in its specific batch. As in, the rest of the data that's not in that batch is not taking up any memory space at the moment. Now, how can we batch the data using the data loader object? Here is the simple initialization of the data loader with a batch size of 4. And as you can see, now before we had batch sizes of 1, now we have batch sizes of 4 of the input and the output. And because we only have 10 numbers here, the last batch only carries 2 elements. We can also shuffle the data as shown here. And lastly, we can drop the last batch to keep all the batch sizes the same. Now we will walk through a pedagogical example of how to put all this together, creating a custom batch sampler. Here we just use numbers with the input being 0 through 9 and the output being 0 through 18 by multiples of 2. So this simple dataset class groups the numbers based on whether it's odd or even. Now, here's an example of what our data set looks like, where the this first index corresponds to the like enumeration of the data, and then this second index is whether it's odd or even. Now, our custom batch sampler takes into account whether we are odd or even, or more generally, whether we're class A or class B. And this can be extended to more than two classes. And based on that, we randomly pick a subset of the class that we care about. And this is a pretty useful technique when we have data that's not normally distributed with respect to all of its classes. And by using this batch sampler, we can ensure that there's no inherent bias in our data set and how we train the model. Now, moving on to the collate function. The collate function is a special function that allows us to increase the customizability in the batching, as in we can perform some data set transformations in the collate function. And here is an example of that, where again, we have our same input and the target values, but now this collate function allows us to normalize the data by taking the mean and standard deviation and normalizing by subtracting the mean and dividing by the standard deviation. And this now allows us to normalize the numbers that we have. Here, these are the actual values themselves, and these are the labels associated with it. Now, lastly, some GPU and memory efficiencies. Num workers is a very important parameter that the GPU uses to distribute the compute and the processing. This will greatly enhance or speed up the runtime, so it's best to increase this as much as possible without throwing any errors. However, once you do see an error, you should not go beyond that, as then the program may crash halfway through your run. And lastly, if set pin memory to true, that is another faster processing technique used. Thank you.